Hey everyone, chapter 2.3 is about bonding. All right. I like to think of bonding as a glue that puts two different atoms together. We chemically combine two different atoms. We will call it, a lot of times the term molecule is used. Technically, the molecules are only what we would call covalently bonded molecules, but a lot of times the term molecule gets used interchangeably, so just a heads up. If we have a combination between two different elements, we would call that a compound. But let's just, for right now, okay, chemical bonds are, like I said, the glue that kind of keeps two different atoms together. We have a covalent bond, and that's where we're sharing electrons between two atoms, and usually they're shared in pairs, although not always. For the purposes of our class, we'll be sharing them in pairs. Here we have two hydrogen atoms. You can see kind of that fuzzy electron cloud, and they're kind of held close together because they have to be close together due to the sharing of the electrons between the two, but you kind of have this melding of the two electron clouds that facilitates the sharing. When we share one pair of electrons, we call it a single bond. If we're sharing two pairs of electrons, we call it a double bond. If we share three pairs of electrons, that's a triple bond. So we have some examples. Here's hydrogen. You can see how hydrogen sharing two electrons. And the whole idea is that they're going to share electrons until their outermost shell is filled with electrons. Hydrogen, its outer shell, can only hold two electrons. So each one of these has two electrons. You can see some other representations of this. We've got Lewis dot, something called space filling. I think this is kind of simulating what the electron cloud would look like between these two. Here we have oxygen, where we're sharing two pairs of electrons. Oxygen's outermost shell holds 8 electrons maximum, so if you actually count, it has 1, 2, 3, 4, 5, 6, 7, 8. So both of them have 8. It's chemically stable because of that. Here's an example of water. You got oxygen. Remember, it holds 8 max. 1, 2, 3, 4, 5, 6, 7, 8. Here we got our two hydrogens that are the H2 and H2O. Here's something called methane, CH4. We have different types of covalent bonds other than the single, double, triple, because sometimes electrons, they don't share equally. Sometimes they share a little bit unequally, I guess. And like, I'm going to explain it a little bit more in chapter 3, but just realize that because of that, we have another guest speaker. Because of that, the nature of the bond is such where, like, one end of the bond will act kind of negatively and one end of the bond will act kind of positively. And I'm just going to leave it at that because we'll go into more detail later. We also have something called ionic bonds, where you get this permanent donation of an electron from one atom to another. And we form what's called an ion, which is a charged particle or a charged atom, meaning it'll have like a positive charge or a negative charge. So, with sodium here, sodium has one electron on the outside. The shell underneath it could be filled if we just get rid of that electron. Interestingly enough, chlorine has 7 electrons in its outer shell, and if we could just get one more electron, it would be filled. So they have a little arrangement here. Sodium dumps off its spare electron to chlorine. So remember, electrons are negative, so since it's getting rid of one negative charge, it becomes more positive. And likewise, chlorine is gaining one negative charge, so it becomes more negative. And the differences in charges, remember, opposite electrical charges attract. So since one is positive and one is negative, that's what's getting them to kind of stick together. And I'll show a little bit, I'll do another video on ionic bonds where you kind of show how they're formed with a little bit more depth. So we call positive ions, we call them cation, not cations, it's cation. And then negatively charged particles are anions. All right. I couldn't remember this for years. Just remember the T kind of looks like a plus. There's a bunch of other ways to remember it, but I think that one stuck the best with me. The T looks like a plus, so that makes it positive. Anyway, so the ionic bond is the attraction between cations and anions. A lot of times we call the compounds that are formed salts. So table salt is sodium chloride. Like the really expensive road salt is calcium chloride. Here's a crystal of sodium chloride. It's probably very pure because I don't think table salt really looks like that. You get the idea. And it forms a crystal, which are like repeating patterns. And that's it for our bonds.